What is the optimal learning rate for neural network backpropagation? Imagine trying to find the perfect speed for a car to drive smoothly without jerking or stalling. That's similar to what we do with the learning rate in neural networks. It's a key setting that controls how quickly or slowly the model learns during training. When training a neural network, the backpropagation algorithm adjusts the model's weights to reduce errors. The learning rate determines how big those adjustments are each time. If the learning rate is too low, the model learns very slowly and might take forever to reach good results. If it's too high, the model can overshoot the best weights and cause the training to become unstable or even diverge. Finding the right learning rate is a balancing act. Usually, you start with a moderate value and then tweak it based on how the loss or error changes during training. A good way to do this is to gradually increase the learning rate while observing the loss. When the loss drops sharply without bouncing around too much, you're close to the optimal rate. If the loss starts to oscillate or increase, the learning rate is too high. There are different strategies to manage learning rates. One popular method is called a learning rate schedule, where you decrease the learning rate as training progresses. This helps the model fine-tune itself as it gets closer to the best solution. Adaptive algorithms like RMSProp and Atom automatically adjust the learning rate for each parameter based on the history of gradients. These methods help keep training stable and efficient, especially with complex models. Another technique is cyclical learning rates, where the learning rate varies periodically. This can help the model escape local minima and explore the loss landscape more thoroughly. In practice, starting with a moderate learning rate and using adaptive optimizers or schedules usually leads to faster training and better results. Understanding the optimal learning rate is especially important in deep learning and specialized artificial intelligence. Models like ChatGPT, DALL, and Midjourney relying on backpropagation and gradient descent to learn billions of parameters. Proper tuning of the learning rate ensures these models learn efficiently without wasting resources or causing instability. From an ethical point of view, choosing the right learning rate also helps reduce energy consumption. Inefficient training wastes time and power, which impacts the environment. Using tools and plugins that help automate hyperparameter tuning, including learning rates, makes training smarter and more responsible. So, in essence, the optimal learning rate is the sweet spot that balances speed, stability, and accuracy during neural network training.